In this lesson, we're going to be getting into imaginary numbers. Oh, come on! Yes, that's right. Imaginary numbers do exist. Kind of. Well, I'll show you. An imaginary or complex number is basically the square root of a negative. We like to represent these imaginary numbers using the letter I, which basically means the square root of -1. And the reason why this -1 doesn't actually exist, whenever you square a number, you're always going to get a positive. If you squared 1, 1 squared, 1 times 1 is 1. -1 squared is also 1. -1 times -1, +1. You're never going to be able to reach this number, square root of -1. If that doesn't make complete sense, that's okay. Just know that it's imaginary, and whenever you encounter a square root of a negative, you're going to have to take that into account. One way in which we do this is simplifying radicals. Whenever I see this negative inside a square root, I'm going to go ahead and right away put an I to designate that this is imaginary. From there, you're just going to simplify your problems like normal. So if we take this square root of 36, that's going to simplify to 6, and we've still got our I. Square root of -36 will simplify to 6i. Over here, we've got this I, square root of 12x cubed. Simplify this like normal, and that's going to give us 2x square root of 3x, simplifying this 12x cubed, and then we still have our I because this is an imaginary number. Moving on, check this out. If you ever multiply two i's, I times I, that's going to give you I squared. Now, when you think about I as square root of -1, that would be square root of -1 squared, which would cancel out the square root, giving you -1. So, an I squared is always going to simplify to -1. That's an important thing to know. Now, if you ever need to simplify an expression that has terms that with imaginary i's, you're going to treat those just like terms. For instance, 3i plus 4i is going to give you 7i. Then we've got the 2 minus 6. That's going to be -4. And we cannot combine these two terms because one is imaginary and one is not. That would be crazy. So we're done. This simplifies to 7i minus 4. Now what about multiplication? We can handle that too. Here we want to just distribute like normal. That'll give us 2 times 4, which is going to be 8. 2 times 5i, which is going to be plus 10i. I times 4, which is going to be plus 4i. And then I times 5i, which is going to be 5i squared. Let's take a close look here at this 5i squared. Remember, I squared is the same as -1. So this is going to be 5 times -1, which would be -5. All right, why is that useful? Well, now that we've simplified that I squared to -5, we can combine these like terms. 8 minus 5, which is going to be 3. Then we also have like terms of 10i plus 4i, which is going to be plus 14i. And there we have our final simplified answer. And that's basically everything. This has been Mr. Zonker, keeping it real.